Okay, guys, you are welcome to our class for today. This is Nobleman Science Tutors Online, and today for our physics class, we are going to be looking at heat energy. And for this particular class, we'll be discussing the concept of heat energy, temperature. We'll also look at some instruments for measurement of temperature. We'll also discuss temperature scales and the conversion between temperature scales. Then, after which, we'll solve some problems. So this is Normal Science Tutors Online. You are welcome to our class for today. If you have not subscribed, please click on the subscribe button, click on the notification button so that when we upload a new video, YouTube will notify you. Also, you can reach us through the WhatsApp number that is showing right on your screen. So I remain Otubo Michael, and as I've always said, please get your writing material so that we can go straight to our class. So please, if you are ready, let's go straight to the class for today. So we are looking at heat energy, right? Okay, so concept of heat and temperature. What is heat and what is temperature? Okay, so this class we're going to be introducing you to the concept of heat and temperature. Heat and temperature. All right, so heat is a form of energy that is called thermal energy. Thermal energy. When you say thermal, it talks about heat. So heat is a form of energy that is called thermal energy. And if you have heard something that you just brought from fire, you will know that heat brings about a sensation of warmth, right? It brings about a sensation of warmth, and it can flow from one body to another when the two bodies are conductors and they are in contact with one another, right? I know these are some kind of daily experiences that we have. If you hold a body, an object that is hot, you feel a warm sensation, and that is heat, right? So heat is the total internal energy of a body, and it is the energy that is transferred from a hot body to a cool body as a result of temperature difference. So heat can only flow from one body to another body if there is a temperature difference. Simply put, if you bring a hot object into like cold water, the hot object will lose its heat because it is transferring its energy to the cold water. And why is that hot body losing heat? It is because there's a temperature difference between the hot body and the cold water. So it is temperature difference that actually allow heat to be transferred from one body to another. Heat is measured in joules, right? And some sources of heat that we have around us is one. In those days, early men, they generated heat by striking a stone against another. So you can actually generate heat by striking a stone against another, by rubbing your palms together. Yes, if you are feeling cold and you want your body to warm, rub your palms together very rapidly. You begin to feel a sensation of warmth. So you can actually get it from that form. Then burning of wood or gas. Okay. Then from the sun rays, thermal energy. This is solar energy or solar heat. So these are some of the sources of heat, and this is just a brief introduction to heat. Okay, so heat energy is the total internal energy of a body, and it is an energy that is transferred from a hot body to a cold body as a result of temperature difference. As a result of temperature difference. Is that okay? So this is introduction to heat. Now we're looking at we're going to look at temperature. So temperature. So temperature is a physical quantity that determines direction of flow of heat. That's what we just said now about heat. So temperature measures the degree of hotness or coolness of an object. And because we are talking about the degree of hotness or coolness of a body, it also measures the average kinetic energy of molecules of a body, because it is the average kinetic energy of the molecules of a body that determines the degree of hotness or coolness of a body. So heat flows normally from a body of higher temperature to a body of lower temperature, right? So that is what we know, and as I've said, it is because of the existence of temperature difference that makes it to flow. So transfer of heat energy is as a result of the temperature difference between two bodies, and temperature is measured in degree Fahrenheit, degree Celsius or centigrade, or the Rankine. So these are some of the unit of measurement of temperature. Right? Degree Fahrenheit, degree Celsius, and so centigrade or the Rankine. We also have Kelvin, right? Temperature is also measured in Kelvin. The Kelvin. So temperature is the degree of hotness or coldness of a body, and as I said, it is a physical quantity. Is that okay? Temperature is a physical quantity. Alright, so we are going to look at instruments that are used to measure temperature. Instrument for measurement of temperature. Basically, the instrument that is used to measure temperature is the thermometer. Okay, and we have different types of thermometer, but we are going to discuss that in another topic. But for this particular topic, the thermometer is the instrument that is used to measure temperature. And in the thermometer, we have two fixed points. The thermometer has the lower fixed point, and then the upper fixed point. The lower fixed point is actually regarded as the ash point, or the freezing point, or the ash point. Then the upper fixed point is the steam point or the boiling point, as the case may be. And then the distance between the upper fixed point and the lower fixed point is known as the fundamental interval. So in most of your thermometer, they can be graduated in either in Fahrenheit or in degrees centigrade. Now, if your thermometer is graduated in Fahrenheit, the steam point of a Fahrenheit scale thermometer is 32 degrees. So the corresponding temperature of the steam point in a centigrade thermometer to that of a Fahrenheit thermometer is 32 degrees. Then the boiling point or the steam point or the upper fixed point of a Fahrenheit thermometer is 212 degrees Fahrenheit. So that is what you are seeing here. On the centigrade scale, the highest point is 0 degree and the boiling point is 100 degrees centigrade. But on the Fahrenheit scale, the highest point is 32 degree Fahrenheit and 212 degree Fahrenheit for the boiling point. So the thermometer has two fixed points, the upper fixed point and the lower fixed point. That's just what I've said now. The upper fixed point is temperature of boiling water at standard atmospheric pressure of 760 millimeter mercury, while the lower fixed point is the melting point of ice at standard atmospheric pressure of 760 millimeter mercury. Then we talk about the fundamental interval. The fundamental interval is the interval between the upper fixed point and the lower fixed point. That is what I just discussed. So please, you take this note so that you understand better. Is that okay? So now we are going to be looking at different temperature scales. So what are the different temperature scales that we have? All right, so here we have the centigrade scale, we have the Fahrenheit scale, then we have the absolute or Kelvin or thermodynamic scale, right? That is denoted as K, the Fahrenheit scale as F, and then the centigrade scale as degree centigrade. This is degree Fahrenheit, and then this is Kelvin. So in the Celsius scale, the centigrade scale, the lower fixed point is 0 degree, while the upper fixed point is 100 degrees centigrade, and that is the scale. Now, the corresponding scale on the Fahrenheit scale, the corresponding point on the Fahrenheit scale, the lower fixed point of a Fahrenheit scale is 32 degree Fahrenheit, while the upper fixed point is 212 degree Fahrenheit. In the Kelvin scale, the lower fixed point is 273 Kelvin and the upper fixed point is 373 Kelvin. And this is what I have represented in this simple drawing. The fundamental interval is the interval between the lower fixed point and the upper fixed point of the scale, and that is the steep point minus the ice point. Is that okay? The steep point minus the ice point gives you the fundamental interval. So for the Kelvin scale, the fundamental interval is 373 Kelvin minus 273 Kelvin, and that gives you this 100 Kelvin. On the Fahrenheit scale, the fundamental interval is 212 minus 32. So if you do that, you are going to have that the fundamental interval for Fahrenheit scale is 180 degree Fahrenheit. Then on the Celsius scale, it is 100 minus 0. So that gives you 100 degree Fahrenheit. Absolute zero of temperature is minus 273 Kelvin. So these are what you need to take note of, because we are going to convert. So we are going to go straight to how you can convert from each of these scales to another. You can actually convert from Celsius to Fahrenheit, from Celsius to Kelvin, and as the case may be. So that's where we are going to right away. So conversion between temperature scales. Conversion between temperature scales. This is what we just saw now, and to convert between temperature scale from one temperature scale to another, you apply this simple relation. Is that okay? This is a simple relation that you apply. Now in this simple relation, you see that the temperature scales are related to one another by this simple equation. Degree F minus 32 all over, this is for the Fahrenheit scale. Degree F minus 32 all over fundamental interval, degree centigrade minus 0, which is the ice point, all over fundamental interval for the Celsius scale, degree Kelvin minus the ice point all over fundamental interval for the Kelvin scale. So assuming you want to convert from Fahrenheit to centigrade or centigrade to Fahrenheit, as the case may be, you will now use the equation that involves the two scales that you want to convert. Okay, so from degree Fahrenheit to centigrade, you bring out this equation. Okay, so assuming take that you are looking for the temperature in the Fahrenheit scale that corresponds to a particular temperature in the Celsius scale. You are looking for a temperature on the Fahrenheit scale that corresponds to a particular temperature on the Celsius scale, or the temperature on the Celsius scale that corresponds to a particular temperature on the Fahrenheit scale. This is the equation that you will use. But finally, this equation will give you this. Okay, so now you equate these two equations together. This is the temperature that you have. Assuming you are given this temperature on the Celsius scale, so this temperature minus the ice temperature all over the fundamental interval is equal to the temperature on the centigrade scale minus the ice point all over fundamental interval on the centigrade scale. So by the time you do your cross multiplication, you will have 180 minus 180 multiplied by the degree centigrade equals to 100 multiplied by the these two, degree Fahrenheit minus 32 in brackets. So by the time you do your calculation, if you divide both sides by 180, you are going to have this. Then if you simplify this further, you will have this equation that is here. If you supply this further, you will have this equation. So if I want to convert a particular temperature in Fahrenheit to degree centigrade, this is the equation that you will use. This is the equation that you will use. Also, if I want to convert from centigrade to degree Fahrenheit, what you just need to do is to make degree Fahrenheit the subject of this formula. And if you do that, you are going to have this. And if you divide 9 by 5, you have 1.8 degrees. So you can use either this to convert from degree centigrade to Fahrenheit, or this. Is that okay? So these are the equations for converting from degree centigrade to degrees Fahrenheit, and from degree Fahrenheit to degrees centigrade, depending on the equation that you are giving. So right away, we are going to solve some problems in order for you to understand this better. Right? So let's solve some equations on what we have just discussed now. Okay, so in this equation, you are asked to convert the following Fahrenheit temperatures to degree centigrade, and you are given first one is 50 degree Fahrenheit. You are so we say that degree centigrade, from that equation, degree centigrade is equals to what? It's equals to 5 all over 9 brackets your degree Fahrenheit minus 32. This will give you your answer in degree centigrade. So you will be giving your degree Fahrenheit to be equals to 50. So substitute this one into that equation so that you have 5 all over 9, 50 minus 32, all in brackets. Okay. So if you work this out, 50 minus 32 is 18. So you have 5 all over 9 times 18 over 1. So when you cancel all this out, this is 2. So 50 degrees Fahrenheit in centigrade will be equals to 10 degrees centigrade. See, so this one is just simple, direct. Similarly, for the second one, you can just do it the way we did this first one. Degree centigrade is equals to 5 all over 9. Put your degree Fahrenheit that is given to you is 120 minus 32. Okay, so if you work that out, you are going to have that 120 minus 32 is 88. 5 all over 9 multiplied by 88 over 1. So if you work that out in your calculator, you are going to have 48.9. This will give you 48.9 degrees centigrade. So basically, this is how to convert from degree Fahrenheit to degree centigrade. Is that okay? Then to convert from degree centigrade to degree Fahrenheit, we are going to do another question on that too. Okay, so this one is to convert the following centigrade temperature to Fahrenheit. Okay, convert the following centigrade temperature to Fahrenheit. All right, so this we already understood this part that we treated already, so I can easily wipe this off, or I can wipe that off and then do a rewrite. Okay, can wipe that off and do a rewrite. That gives me, let me just do a rewrite so that to not look somehow. Okay, over 18. So this cancel, this is 2. We have our 10. Okay, so that is it. Now, to convert from degree centigrade to Fahrenheit, we still use the equation that we just got. Okay, so degree centigrade to Fahrenheit, you have your degrees Fahrenheit is equals to 9 over 5 degrees centigrade, okay, plus 32. So what this simply means that you find 9 over 5 or the degree centigrade you are giving, then add your answer to 32. That is what it simply means. So for this first one, you say degree Fahrenheit is equals to 9 over 5 times 60. Whatever you have, add it to 32 to give you your answer. Okay, so 9 over 5 of 9 over 5 of 60 multiply first 5 can divide 60. Okay, 5 can divide 60, so that you have if 5 divides 60, you are going to have 12 there. Then multiply, you now multiply 12 by 9, then add up your answers. By the time you do that add, you will have your overall answer to be equals to 140 degrees Fahrenheit. This is what you will have as your final answer, 140 degrees Fahrenheit. Okay, so that is how to apply these equations for you to solve any problem. That is how to apply them. Is that okay? So I hope this is simple. Let us do the other one. So that this is the number 1. So let's do the second one. So for the B, just as we did for the first one, degrees Fahrenheit is equals to 9 over 5 times 115 plus 32. Okay, so if you work that out, you will have 1035 all over 5 plus 32. So use your calculator to punch that out, and then you have, don't forget the minus sign. Don't forget the minus sign. So when you work out everything, you are going to have minus 175 degrees Fahrenheit. That's okay. This is what you have, minus 175 degrees Fahrenheit. Because by the time you multiply 9 times 115, it will give you 1035. Then divide by 5, then add up your answer. You have 175 degrees Fahrenheit. Okay, so this is how to convert between centigrade and Fahrenheit scales. I hope this one is simple and it's easy for you to understand. So we'll move on further. Okay, so this is conversion from centigrade to Kelvin. Just as we did for the other one, this is the temperature that you don't know, and this is what you know. So you want to convert, or you want to find a corresponding temperature. This is the highest point for the Kelvin scale, and this is the fundamental interval, just same thing as this. So by the time you do your cross multiplication and all that, you are going to have that for you to convert from degree, from Kelvin to centigrade, this is the equation that you will apply. Then from centigrade to Kelvin, this is the equation that you apply. Okay, so we're going to solve a problem now, just to drive on these points immediately. Okay, so this one question says convert from centigrade temperature to Kelvin temperature. Convert from centigrade temperature to Kelvin temperature 40 degrees centigrade. Okay, so you have been given your temperature in degrees centigrade. So we'll say that Kelvin is equal to degrees centigrade plus 273, or this one in Kelvin. So just substitute that so that you have 40 plus 273, and that gives you um, when you add up all this, you are going to have 313 Kelvin, 313 Kelvin. So this one is simple and it's direct. So this has to convert from degrees centigrade to Kelvin. If you are converting from Kelvin to degrees centigrade, you just subtract 273 from the Kelvin that you are giving, just the reverse of the equation. So let's solve another problem in this regard too. Okay, so this question says convert from Kelvin to degrees centigrade. So just like I said, you are looking for your temperature in degrees centigrade. So for you to do that, you are going to have your Kelvin minus 273. So if you put that, you will have that 300 minus 273. So that gives you your answer in degrees centigrade, and your answer will be equal to 27 degrees centigrade. This is 27 degrees centigrade. Okay, so application of these equations are easy. Now this is your test point. Test your understanding. Please solve all these questions so that you have a better understanding of what we have discussed. That okay? You can put your answer on the WhatsApp number that is showing on your screen, and then you can also give us a call so that we can discuss and see how far we can help you more, so that you have more better understanding of physics. Okay guys, so this is where we are ending this class, and I hope to see you in our next class. But if you have not subscribed to this channel, what are you waiting for? Please subscribe to the channel, click on the notification button so that when we upload a new lecture video, YouTube will notify you. Also, you can reach us through the WhatsApp number that is showing on your screen, and if you have any challenge in physics, we can actually discuss it. This is Nobleman Science 2000 Online. We are bringing physics class direct to your doorstep. We are bringing it direct to your doorstep. So please, if you like what we are doing, encourage us, give us a like, give us positive comments, and then you can also invite your friends to come and join this channel. And if this is your first time of visiting this channel, you are welcome to our physics class online. Thank you so much for your time. We hope to see you in our next class. Thanks.